let's say we have this quadratic equation with three coefficients a, b and c. Now if we choose a to be equal to 2, b equal to 5 and c equal to 50, then this quadratic equation becomes this. Now we can plot this equation with x ranging from 1 to 20, and then further we will go ahead and select 3 points in the curve at x is equal to 5, x is equal to 12 and x is equal to 18, and these are the corresponding y values. Let's say for some reason we forgot what are those coefficients are. We only know that this is a quadratic equation, and further we also totally lost the curve, except that we only know these 3 points and the coordinate of those 3 points, and the x coordinate of those 3 points are 5, 12, 18, and y coordinate is 125, 398 and 788. Now we only know this information, and we are asked to find what is the value of a, what is the value of b, and what is the value of coefficient c. So we can use optimization to find these values. To do that, so we have to find something called cost function. To build up the intuition towards that, let's say this quadratic equations coefficient, we rename them. We rename such that a is coefficient 1, b is coefficient 2 and c is coefficient 3. Now we can just rewrite this equation to be y is equal to coefficient 1x square, which is ax square, and plus bx means coefficient 2x plus coefficient 3. Now if we take this point and put the value of x and y in here, so we get y is equal to 125, and put x value here. For x square we put 5 square, for x we put 5. So this is this equation is evaluated at this point, gives you this equation. We can put all the quantity to the left, so that means this minus 125 should be equal to 0. Let's say, as we don't know what are the values of these, so we start to guess. So one of our guess was coefficient 1's value is 1, coefficient 2 the value is 4, and coefficient 3 the value is 60. So let's say see what happens if we choose these values. So these are the coefficient values we put into this equation at x value of 5. So x value of 5 square 5, and if we put this value corresponding to this coefficient and just add them up, we get a value of 105. Whereas if we have done the right guess, or if we have already known this coefficient, this value would have been 125. So making a wrong guess of coefficient has a penalty or an error, or we can call is the cost of our mistake. So we know that at 5 square 5, and if there is a right guess of these coefficients, the value of this summation should be 125. So we can say that this is the cost. That means if we choose the right coefficient, the cost is 0, and if we choose the wrong coefficient, then we have certain amount of cost. For example, we could have probably chosen coefficient 1 to be 2, coefficient 2 to be 9, coefficient 3 to be 20 or something. Then this cost would be different, because choosing these values, the cost was 20, because instead of 125 we got 105, or maybe minus 20 the cost. So there is a cost for putting the wrong guess. So let's put that this cost is for this point. Similarly, we can find the cost for this point to be this same thing: coefficient 1, coefficient 2, coefficient 3, put the x value to be 12, and the y value we know is minus 398, and if we had the right guess it should be 0. If we had wrong guess, there should be cost. And we do the same for the third point. So we have these three costs. What we do next is we add up all those costs. We just add this left part of this equation, or the cost, this plus this plus this, and we get that. Not only that, because if we have positive cost here and negative cost here, both are cost, I mean both are error, but if we add them positive and negative, they will cancel each other to certain level, and it will show that you don't have much error. So to not to get into that trap, what we do, each cost we are gonna square up. So we have squared up each cost, this cost square plus second cost square plus the third cost square. So this quantity is our cost, and once we know how to set up our cost, it is just 1 or 2 lines that we optimize and really get the value of those coefficients very accurately. Now we look, so these are the x coordinates and these are the y coordinates. So we don't need them because we have already put in our cost function the x and y. So we have built this cost function as a function of cof, and in cof we have cof1, which should be the value of a, cof2 which should be the value of b, and cof3 which should be the value of c. So we have just written this particular equation as our cost function, as a function of cof. So this cof includes cof1, cof2 and cof3. So once we have defined our cost function as a function of cof, we can just use this fmincon function in MATLAB, and within fmincon we will put our cost function first, and then we will put our initial value because we don't know what's the value of ABC. So we say like, okay, start guessing that they all are 0, and then search for what value gives us the minimum cost. So as you know, the minimum cost means we have the right guess. So it will keep searching for this upper and lower bound. So it will keep searching for the a value to be from -20 to 50. So this is the lower value or limit of a. It will search for value of b between 20 and 50, and for -20 and 50, and for c again -20 and 50. So these are the setup that you need to do. So you define your cost function in fmincon, you put the cost, you put where to start from. It will not matter much. You can start from 10 10 10, 20 20 20, it's fine, you will still get the same result. And then in the range you can widen the range. If you don't know that, if you think that okay, b, the value of b could be -200, you can just put here -200. It is not a big problem. Probably if this range is too wide, it will take a bit extra time to do the optimization. And there are 4 brackets in between your initial guess and your lower and upper limit. So these brackets are some other linear relation coefficient that you provide to help the optimization algorithm. As you don't know what are those values, you just put these 4 third brackets in between, and actually you are done. So let's recheck what was our initial value of these coefficients in the first slide. So our value as A or cof 1 was 2, B or cof 2 was 5, and C or cof 3 was 50. Now if I click run, it will optimize for the cost function and try to make that cost as low as possible, and then this cost as low as possible, and give you the cof values that makes the lowest cost. So let's run it, and it was very quick. It gives cof value of 2, A is equal to 2, B is equal to 5 almost, and C is equal to almost 50. So 2, 5, 50. And initially when we started, yes, our coefficient values are 2, 5 and 50. 2, 5 and 50. So very quickly now we have retrieved what should be our coefficient values. So this is a very simple example that how you can use optimization. But there are wide use of optimization that for many complex cases you can find those examples in our channel.